Hello everyone, my name is AMMAJI DUPPADA, and today we are going to solve two problems comes under complementary function as case 1 and case 2. Actually, in the last video we have seen already what is the complementary function and what is the particular integral in solving the linear differential equations of higher order. Now, straight away we will see two problems. And then remaining cases also we will cover in complementary function, and we will see the how the proofs against each case. Now the question is d square over dx square minus 1 into dy by dx minus 2y is equal to e to the power x. So now I am going to find complementary function. Remember to find complementary function. Actually, complete solution is equal to complementary function plus particular integral. But anyhow, here in this problem, we are asked to find complementary function only. So we no need to find particular integral. Coming to find complementary function, you have to make input is equal to 0. In the theory, we have covered this. So input should be equal to 0. Now, what is input actually here? E power x is the input. So my equation I will write like d square y over dx square minus dy over dx minus 2y is equal to 0. Now, this d square over dx square is an operator. D square I can write over y minus d by dx is an operator. D I can write minus 2. These three are operating on y is equal to 0. Now you have to find auxiliary equation. What is the auxiliary equation? D square minus d minus 2 is equal to 0. Now, so from this auxiliary equation, you have to find eigenvalues. How to find eigenvalues? You have to solve this polynomial equation of order 2. You can solve any manner like d square minus 2d plus d minus 2 is equal to 0. That implies d if you take common d minus 2 plus 1 if you take common d minus 2 is equal to 0. Then d minus 2 if you take common, you will get only d plus 1 is equal to 0. Now what are the eigenvalues? D is equal to 2 is one eigenvalue, d is equal to minus 1 is one eigenvalue. Now straight away you can write solution. I told you already, if m1 m2 are the roots, how it looks like. What is the complementary function? Answer is there are two roots or two eigenvalues in this equation. So two arbitrary constants will come. So c1 into e to the power m1x plus c2 into e to the power m2x. That's it. What is c1? C1 is a constant, arbitrary constant. E power m1 means first root, e power 2x plus c2 arbitrary constant 2 e power m2x. m2 is minus 1 into x. That's it. This is the way you have to find complementary function of any linear differential equation. So this is what actually case 1 is. Very simple. Now we will see the case 2. So now case 2 is looking like this. So now here also I have to find actually complete solution again. Complete solution is equal to, I told you, it is complementary function plus particular integral. But here we are asked to find only complementary function. So to find complementary function, what we have to do? We have to make input is equal to 0. It means whatever they have given in the right hand side of this equation, you can neglect. If they give 0, then there is no problem at all. If they have not given 0, you have to make it equal to 0 to find complementary function. So now this equation, now I can write in terms of operators directly. D square plus 6d plus 9, each one is operating on y is equal to 0. Now find the roots of this Now what is the auxiliary equation? D square plus 6d plus 9 is equal to 0, because y never be equal to 0, because y is our output, like y is our output. That is what we call complementary function. So find the roots. D square plus 6d, you can write 3d plus 3d plus 9 is equal to 0. Now d square, okay, you can take d common, you will get d plus 3 plus 3. If you take common in the two terms, d plus 3 is equal to 0. It means d plus 3, d plus 3, two factors came. It means two roots. D is equal to minus 3, comma minus 3. Remember, now roots are repeated. This is case 2. Roots are repeated. So in that case, how to write complementary function? That is complementary function, nothing but y is equal to c1x plus c2 into e to the power, because only single root, m1x. So how to write? C1 is arbitrary constant, C2 is arbitrary constant, e to the power, what is m1 repeated two times? Minus 3. So e power minus 3x. That's it. This is the solution of the given differential equation. But remember, you should get some doubts actually in this case. Why we need to write? Why I need to understand this bluntly? C1x plus C2. If roots are 3 repeated, C1x square plus C2x plus C3. How this came? Right? This is generally doubt will come like for everyone. So if you understand this too firstly, then now we will see what is the proof behind writing this equation or complementary function in this form. Not only this form, even in the first problem we have seen in different way, like c1 into e power m1x plus c2 into e power m2x. How this equation we have written. So if you want to prove how this solution we got, that we will see in the next session. Thank you all for watching this video.